Welcome back to my channel. I hope everyone is doing great. Let's solve 10th problem of dynamic programming study plan. The problem statement states, given a triangle array, return the minimum path sum from top to the bottom. For each step, you may move to the adjacent number of the row below. More formally, if you are at index I on the current row, you may move to either I or I plus 1 index on the next row. Okay, let's look at this particular example. Given this triangle, let's say you're standing on this particular index in this current row. From this particular index, you can either go to this particular element or this particular element. Okay, if you're standing here, you can go to this element or this element. If you're standing here, you can go here as well as here. Okay, now you have to identify the minimum path sum to reach from top to the bottom. Okay, you not necessarily you have to reach to a particular index of the last row. You can land at any of the index, but the path which you take should contain the minimum sum. Okay, for this example, if you start at 2, you can go either right or left. If you take 3, then from here you can go this way or this way. Let's say we have taken this path. From here you can go this way or this way. Let's say this path. Okay, this is the path which is contributing to the minimum sum. If you choose any other path, it will contribute to a sum which is greater than 11. Okay, so let's try to generalize this. Okay, let's say we are standing at ith row. Okay, let's say we are standing at the ith row and the jth column. Okay, so answer to reach from this particular cell to the last row is basically you have to add this to the result, and from this particular position you can go either to this position or this position. That means to the next row, you have to go to the next row to the same column, or you can go to the next row to the next column. So these are the two options I have, but since we are trying to minimize the answer, we have to take minimum from these two. Okay, so answer to my current cell would be a of I comma j, which is the value at the current cell, plus answer coming from the next row same column and the next row next column. Okay, and if you have, let's say you have reached, there are no more rows to, when index I exceeds the total number of rows I have, that means the answer should be returned as 0. Okay, if you draw the tree diagram for this recurrence relation, you will notice that there will be certain overlapping problems. Okay, if you see, answer to this is depending upon these two values, and answer to this is depending on this and this. Okay, if you see, these two problems are relying on this particular sub problem, answer to this particular problem, right? In the similar way, you will notice answer to this will depend on this, answer to this will also depend on this. So there are various sub problems which are actually overlapping, so you don't have to recompute the answers again and again. You can simply cache it and reuse it whenever it is required. Okay, so this approach is known as dynamic programming. You can code it in the top down fashion or in the bottom up fashion. Okay, I will show you the top down fashion first. Okay, so in the top down fashion, we'll simply replicate, we'll just write a recursive function and then replicate this recursive relations. Okay, so let's say f is a function which will take both the indexes and return me the answer. So once you reach or exceed the bounds, total number of rows you have, then we will be returning 0, or else we will be calculating the answer from the next row current cell and the next row next cell. Okay, so since, as I mentioned, the problems will be overlapping, we will be maintaining a global DP array. Okay, and if the answer to the global DP array is not calculated so far, if it is calculated so far, then we will be returning it. If it is not calculated, then we'll calculate it and store it here. Okay, in the end my overall answer will be coming from f of 0 comma 0. Okay, here I've just initialized DP array and store it at the class level. Okay, if you submit this problem, you will notice that all the test cases will be passed, and it will be pretty efficient solution as well. It has beaten 99.81 of the solution so far. Okay, and if you see, what is the time complexity for this? We are trying to calculate the states which are present in this 2D DP array. So the overall space complexity and the time complexity will be big of n square. Okay, this is top down approach. Okay, if you keenly observe, okay, at any given state, answer to the current row is only relying on the answer to the next row. Okay, answer to this row will only rely on the so far answers calculated here. Okay, so there is a scope to optimize the space complexity over here. Okay, so in the top down approach, there is no way you can optimize the space complexity. If you want to optimize your DP solutions, you should always look at your bottom up approach and try to optimize over there. Okay, yeah, I will show you now how we can optimize the bottom up approach. Okay, so let me just copy these values to the bottom so that we will be using it. So yeah, let's say we have these values. Now we have to compute the answers in the bottom up approach. So what I will do, I know answer to the last row. Okay, if I have to reach from last row to the last row will be same as the values which are present in the last row itself. So now that I know answers to reach to the last row from the last row itself, I will be calculating answers to reach from last but one row to the last row. So in order to calculate answer to reach from this to last row, I can go in these two ways. So answer to these two is calculated and stored in the array. Okay, so I will be taking minimum of these two plus the current value, so which will be 6 plus minimum of both the values, which will be 7. Now in order to calculate this, 5 plus minimum of these two, which will be 5 plus 1, which will be 6, and in order to get the answer for this particular cell, 7 plus minimum of these two, which will be 7 plus 3, which will be 10. Okay, so instead of storing it in a separate array, what we'll be doing is we will be overriding the values in the existing array itself. Okay, so we have 4 1, so 6 plus minimum of these two, which will be 6 plus 1, which will be 7, so I will be storing 7 over here. Now 5 plus minimum of so far calculated answer, so 5 plus minimum of 1 comma 8, which will be 1, 5 plus 1, which will be 6, 7 plus minimum of so far computed answer, which will be 7 plus 3, which will be 10. Now that to answer to this particular row is present in these first 3 columns. Now in order to calculate answer to reach from this particular cell to all the way till the end, I will be taking 3 plus answer from these two, minimum of these two, so which will be 3 plus 6, which is 9. Okay, now in order to reach from this to the end, I will be taking minimum of these two plus the current value. Minimum of these two is 6, 6 plus 4, which will be 10. Okay, now that you have answers to reach from this particular cell to the end is these two values. Now in order to reach from this cell to all the way till the end will be current cell plus minimum of these two, which will be 2 plus 9, which will be 11. So my answer to reach from top to the bottom is basically the 11. Okay, if you see this and this is actually satisfying same basically. So the overall space complexity is basically big of n, where we are storing all the elements in a single array of size n and we are overriding values, right? So let me show you the code implementation of this approach. As you can see, as I mentioned, we will be requiring a DP array of size n, where n is the size of the triangle. Okay, now the answer to the last row, okay, answer to the last row will be the corresponding values itself. So DP of I will be, I'm just overriding all the DP values with the last row values. Okay, now I will be starting from last but one row, and I'll be starting from last but one row and filling the values with the current value plus minimum of current column plus the next column. Okay, so I will be going from 0 all the way to the row value, and DP of j will be the cell value plus minimum of DP of j plus DP of j plus 1, and then my answer will be present in DP of 0. Okay, if you submit this problem, this will be pretty efficient solution. Okay, in terms of space complexity. Let's just return bottom up of triangle and let's try to submit this. As you can see, it has beaten 92.66% of solutions in terms of memory. Okay, if you see the space complexity, we are just using a dp array of size n, so space complexity is big of n, and the time complexity is basically big of n square, which will be remaining same. Okay, so that's all about this problem. If you like the explanation, hit the like button, hit the subscribe button, and also share your valuable feedback in the comment section. I will be posting the solution in the description as well as in the pinned comment. Feel free to check it out. Thank you.